So hi, my name is Simon Brown. I am the Technical Product Manager of Acoustics Solutions here at L-Acoustics. L-Acoustics have been at the forefront of loudspeaker design for the past 40 years. Our sound systems can be found in venues and on tour all over the world. We are the pioneers of the line array technology, which was driven by the sole aim of providing a high quality and consistent sound experience to all over the audience. In more recent years, we have developed our ELISA technology that with increased loudspeaker configurations and our object-based mixing algorithms can provide a heightened sense of realism. And also with loudspeakers around the audience and overhead, we can provide a more immersive sound system which provides greater creative control for sound engineers and creatives. So all of our innovations have been driven by the sole vision of creating a human connection through sound. The power of a live event is in that sense of connection, and we believe that high quality audio can evoke a unique emotional response that is key to bringing experiences and live events to life. So in recent years we have broadened our focus not just from the sound system but to the room itself. A sound system does not work in a vacuum. The room is a critical component to one's response to a live performance. And I've worked for many years as an acoustic consultant before joining L-Acoustics, and my role here is to sort of fully understand how a loudspeaker system and the acoustics of a space can work together to provide the best possible experience for audiences and for performers. In order to do this, it is key that you have a good understanding of the acoustic properties of a room, and Treble is a fantastic tool for being able to simulate how a room will respond to a sound system. So our hyper-real immersive sound spaces, or HYRISS, aim to bring this concert-grade audio to a much smaller scale, be that the home, hospitality, or a corporate setting, for example. It consists of a 3D network of loudspeakers on the walls and in the ceiling, and this allows you to have ultimate flexibility for how you use sound within your space. This could be a movie with a Dolby Atmos soundtrack. It could be a stereo track that you could pan to any place within the room, or it could be a fully immersive audio track that completely surrounds you in sound. Also, with our active acoustic system ambience, this allows you to adjust the acoustic energy within the room to meet the need of the event. This could be if you have a party, for instance, you can increase the sense of acoustic energy within the room. If you had a conference or a voice event, it would allow you to boost the clarity of speech. Also, if you had a music rehearsal, say, or a piano recital, for instance, you could extend the reverberation time to bring out the best in the music for the audience. Our HYRISS showroom, which is in Highgate in North London, is a room which is approximately 80 square meters in floor area with a ceiling height of between 3 and 4 meters. It has 16 loudspeakers on all 4 walls and 12 speakers overhead. As you can see when you look around the room, you cannot see where the loudspeakers are placed. They are perfectly integrated with the architecture of the room, hidden within recesses within the walls and the ceiling. This integration with the architecture is a key aspect of HYRISS, and it extends not just to the architecture, but to the lighting control and design and the rest of the AV systems, and also includes the acoustics. The acoustic aim of this space is to provide a controlled acoustic like you would have in a studio. This allows the sound of the speakers not to be coloured by the space overly when you're in a setting for cinema or for high critical listening of music, for instance. But we didn't want the space to be so dead that when you were in it in a home environment or just naturally in the room that it felt oppressive. And also wanted enough natural acoustic energy within the room that for our active acoustic system to operate, it could then effectively regenerate this natural acoustics of the space. So we had a target of reverberation time of approximately 0.4 seconds was our aim, and we wanted this to be flat over the audible frequency range as low as possible. The low frequency performance is key for a loudspeaker system, and in a room of this size, room modes could lead to potential inconsistencies in the room response. And we wanted to understand this, and we believe that Treble's wave-based algorithm would be a very useful tool for understanding this and helping us make the right design decisions. So our design for the showroom started, as most acoustic designs do, with a 3D model. This was done within SketchUp. Importing this SketchUp model into Treble was very, very pain-free. There's a useful plugin for doing this. It also provides very useful feedback onto the integrity of your model, so you can easily visualize any potential errors. This was a very pain-free experience. Our next step was to carry out acoustic measurements in the untreated room. This allowed us to calibrate the initial acoustic model to understand the acoustic properties of the residual surfaces, such as the plasterboard walls and the floor. So we could create new materials within Treble very easily with their material builder to adapt to these measurements and to ensure full accuracy of the acoustic model. Once we did this, we were then able to trial our different design options with thicknesses and location of absorption. It became quite clear that we initially didn't have enough area. We were contending against large reflective surfaces, such as our AV screens and the sheer number of loudspeakers. We needed to find some additional area to bring the RT down to its design target. We were able to find this in areas high up on the walls and the ceiling, and this proved very effective. Another design concern was that of flutter echoes. We have large AV screens in a room with a very low RT, so this was a potential problem. But luckily, with the use of Treble's reflection tracker and with the auralizer and the hedgehogs, we were able to assess different loudspeaker positions, whether they would cause any flutter echo issues, and we came to the conclusion with a good degree of confidence that actually this wasn't going to be a problem in this room. The result is a space of the highest quality and really shows the possibilities of how you can integrate a high-quality sound system with the architecture, with the lighting, with the AV, and with the acoustics of a room. Treble was a key factor in the design of this space, and particularly understanding the acoustics performance at low frequencies. As you can see when you compare the measurements of the finished result with the Treble prediction, the accuracy at low frequencies is vastly superior to that of a basic geometric modeler, and this was crucial for us understanding what we needed to do to make the space the best place it could be.